Hello, AGP students. This is the May 2018 Section 4 test. And within this, we're going to be going through the answer solutions on this problem, on this section of the test, and kind of helping you better understand, what you should be probably looking for and how to try to solve these questions a little bit more effectively and things. So what we have here, it's pretty easy. Just noticing we got these weird graphs here. And for that reason, remember these questions are these are called graphing interpretation of things. So we have some information that's given to us, and then we kind of want to see which one is best representation of it. And it says here, a gravel company had 30 tons of gravel in stock at the end of the day on Monday. So it had 30 tons end of the day on Monday. So if we kind of look at that, we can see that the gravel times the day looks like kind of what we have. So we have 30 tons, 30 tons, 30 tons. So that doesn't really help us. On Tuesday, the company shipped 10 tons of gravel and received no delivery. So I guess that means that they had a net loss of minus 10 on Tuesday. So here, A, you see that increases, so that can't be it. Same thing on B, same thing that. And then C goes down and D goes down. So those remain intact. So on Wednesday, the company made no shipments and received a delivery of 20 tons. So that means that there's a plus 20 there. And so Wednesday, we see going back up 20 plus 20 plus 20. Same thing there. Okay, on Thursday, the company made no shipments, received no deliveries. So that's where you see this piece is wrong, and we see D is the answer choice. So as you kind of go in, you want to do peeking of these answer choices. And it's a very simple problem, but one that we want to make sure we have to get right and going through and eliminating answer choices. So question number 2, we see that what we have here is we have this variable underneath the radical, so that automatically that tells us that we're dealing with a radical equation. Okay, so, sorry, it's Q there. So what we want to do, let's go ahead and pull this out. We have the square root of 2x equals 8, and we want to be able to square this and then square this side. I just want to know what the value of x is, so just pay attention to that. So that eliminates the radical on that side. 2x equals 64, divide by 2, and we get x equals 32, which is answer choice C. All right, this one, it seems like we're trying to create an expression that is equivalent to this one. So if 10 equals 2x plus 14, which of the following must be true? Of things, and so seeing as to which one would also yield a similar value of x. So let's solve for the first part. So 10 equals 2x plus 14 and minus 14 minus 14. So negative 4 equals 2x, or we get negative 2 equals x. So which other one would do that? That's a positive. That's a positive. We divide by 8. We see we get negative 2. So C is the answer choice on 3. So look at number 4. It says the hardcover books produced by a publisher have pages that are 0.1 millimeter thick and a front cover and a back cover that are 2 millimeters thick. Which of the following gives the total thickness, f of n, in millimeters of a closed book that has pages? So we see what we have here is a function. And remember, these functions are set up just the same as a slope-intercept form. Actually, sorry, that's a little bit backwards there. Let's turn that around. Let's see. So we can see that is going to be y equals b plus x. Well, and the b's that we could take, and it's going to be, we have a front and back cover. They're both 2 millimeters thick. So we know the front cover is 2 millimeters, and we know the back cover is 2 millimeters. So that collectively is going to be 4 millimeters at a minimum. So just based on that and that information alone, that's wrong, that's wrong, that's wrong, because that's the constant there. You've got to start at least 4 millimeters. A is the answer choice. And so we can eliminate everything else based off that right there. All right, so let's look at number 5 here. It says that a teacher has signed up for a program that automatically delivers books for the classroom library. The classroom library consists of 48 books. That's what they have currently. If the program delivers 12 books a month, so we can see we get 12 books per month. Oh, that's really bad on my handwriting there. How many books will the classroom library consist of after 5 months? Well, here we're developing another linear equation. So we see that we start off with the b is 48. We see the slope is 12. And here the x is 5. So the equation is y equals, which normally will be 12x plus 48. 12x. So then that would then be 12 times 5 plus 48, which will then give us 60 and 48, so it gives us a total of 108, which is B. And so again, we're developing a linear equation on that one. And solving. Okay, so let's look at number 6 here is what we have. It's discussing what this is. It says the area enclosed by a circle, okay, is 25 square inches. And so that's telling us that the area, the area circle is equivalent to pi r squared, which is equivalent to 25 pi here. So that should tell us that the area is pi r squared, and that should tell us that the radius of this is 5, because remember, pi r squared is equal to 25, so it means r is there. So what is the length in inches of the radius? What is the length in the inches of the radius of the circle? So since we know this is equivalent, r squared, we see the answer choice. Our number 6 is 5. All right, so let's look at number 7 here. Number 7, and what we have here is we could see is says an analysis of a random sample of a type of laptop computer estimated that the mean working time was 4.7 hours. So we can see the mean. And so we see the mean. Let me go down here actually. So we can see the mean is equivalent to 4.7. And the margin of error, so the MOE, is 0.7 hours. We see that here. And remember, margin of error just means it's given us a range of sorts of where things are likely to fall in. So we know between the margin, because MOE, that means that the range of this has to be between 4.0 and 5.4. So let's look at this. It says this type of laptop computer has a mean working time of at least 4.7 hours. And so that doesn't really seem appropriate to anything like that, because it could be less, and so it's not at least the things. This type of laptop computer has a mean working time of at least 5.7 hours. So that's definitely not right, because that's well outside the mean, as we established it's somewhere between 4 and 5.4, so not it. This type of laptop computer has a mean working time between 4 and 5.4 hours. Yes. And this one here has a mean working time of 0. So yeah, that's definitely wrong. So answer choice 7, C, talking about the margin of error here. All right. All right, so number 8, what we see here is that we have this expression, this linear equation. It says equation line L on the xy plane is shown above. Another line K has a slope equal to double the slope equal to double the slope of L, and a y-intercept equal to double the y-intercept of L. At which point at xy do lines L and K intersect to things? Well, one thing we can understand about it says that line K has a slope equal to double the slope of L, right? So if it's double the slope of L, we see the slope of L here, because this is line L, right? You see, and if it's double that, and if that's 2, then it has to be 4. So line K has to have a slope of 4, right? And it says, and a y-intercept equal to double the y-intercept of L. So reading here, y-intercept equal to double the y-intercept of L, which point next will do line K intersect? Well, if the intercept here is at 7, then that's going to suggest that the intersect of this other one is going to be at 14, okay, because that's 7 there. So this expression here is going to have to be y equals 4x plus 14, right? And then up here we have y equals 2x plus 7, all right? And because of that, it wants to know what is going to be the, at which point do x and y lines intersect. That means systems, okay? We then have to join here between these two, all right? And so as you're joining between these two, that you got to connect those. So we have 4x plus 14 equals 2x plus 7. All right, so we'll move this piece here, and so for that reason we get 4x minus 2x equals 7 minus 14, and so within that we get 2x equals negative 7, and so we see the x for this one is going to be negative 7 halves. Well, the only answer choice that matches that is A, and so we don't even have to solve for the y on this one. All right, looking at number 9, what we see here is we can kind of notice just by looking at it, talking about gallons and miles, and things of that nature and stuff. So let's just try to read it. It may be a rates problem here, but in the normal weather conditions, a particular type of jet fuel burns an average of 24 gallons of fuel per nautical mile. So we can see 2.4 gallons per. Remember, per means a fraction relationship per nautical mile, right? The distance from New York to Los Angeles is 2,100 nautical miles. Approximately how many gallons of fuel will a jet burn for a trip from New York to Los Angeles in normal weather conditions? So this is a pretty easy rates problem. You see we're at the distance is 21 nautical miles between New York and LA, right? Let me make this a little bit cleaner here. So let's do this. So we're at 21 nautical miles, and we want to be in gallons. That's essentially what we want to be, is how many gallons. So we have to take this thing and sort of flip it around here. Flip it around. And so what we can do is, because what we want to be is in gallons. So multiply by the converting factor. So we can say, actually, I'm sorry, we want to be in gallons, right? So we can say 2. Oh, Jesus, this should be 2,100. A little bit. All right, let's try this again. 0, 0, 1, 2. So 2,100, 2.4, and that's 2.4 gallons per each nautical mile. So you see what we're doing is we're eliminating the nautical miles here, and then we're left with just a unit of gallons, right? So, and multiplying that, we can see as we do on the calculator, so be about multiplying 2,100 times 2, so that's going to give us, oh, what the heck's going on here? Times 2, so that's going to give me 4,200, and then 0.4, which is less than half of 2,100, is going to be about another 1,000. So we can see that we're approximately going to be looking at this answer choice is going to be approximately 5,000 gallons that we'd have to use on this one. All right, guys, let's look at number 10 here that we have. What we can see in looking at this problem is that we realize we're dealing with something in the vertex form. Remember, the vertex form is when we have something that's y equals a to the x minus h squared plus k. And so remember, the a here has to deal with the slope or stretch. Remember, so that talks about how wide or narrow your parabolic function is going to be. This is going to be horizontal shift, so that's going to be right and left. and then the k is going to be vertical shift, which is up and down. So let's take a look at this one. Saying the quadratic function is defined as f of x equals 2 to x plus 2 squared minus 1. And you explain which would be the graph if it shifted 3 units to the right. 3 units to the right. So first we kind of have to identify what this may happen to resemble. Well, first, the a is positive, and so for that reason, this is a negative parabolic function. So this one's out. That's positive, and b is negative. So those two are out just based off seeing that the a is positive here. Next thing we know, we see it's at -1. That's the next easiest thing to sort of determine. We see, so that's definitely below, and that's definitely below. So we can't necessarily eliminate anything because of that piece right there and stuff. But looking at this last piece, it says x plus 2. Now remember, the horizontal shift here, it's opposite of what it may happen to be. So if this is positive 2, then we really know that the parabola's vertex is going to be somewhere over here. And so this one is suggesting that it's already at that value. And since it's at -2, okay, the vertex is going to be at -2, -1. That's the vertex on this one. Then if we're shifting it 3 units to the right, remember if we're shifting 3 units to the right, that's going to move that over to a +1, so -1. And so for that reason, it has to be B, and C is wrong. So C is really describing what you have here, the things, while B is describing what it's looking for. Okay, so let's look at the next one. We see that we have another systems problems, and so there's a couple ways that we could solve for this. When we see that we have this sort of special, we have this x plus y here, and so anytime that we see this, we kind of want to see if there's any special patterns in here, and not really. I mean, we could try. Normally what I try to do is I try to add them up and see. So I'm going to get 9x plus 3y equals 39. And so they're all divisible by 3. I see that. And so if I was to pull that out, I could see I'm going to get 3x plus y equals 13 of sorts. Okay. So that kind of, or sorry, that equals, whoops, that should be 39. And then I got to divide by 3, and then divide by 3, and so then I get 3x plus y equals 13. However, it's asking for x plus y here. So, not really super helpful in trying it this way, but normally when you see these x plus y's, the first step you want to try to do is see if you can't cut through it in some ways. Now, we might be able to use this for later on or stuff, but this isn't going to, sometimes you can cut straight through it and find what you need to in just those few steps. So what we can do, we can eliminate the y's, and so I can, let me try and do this. I could multiply everything by -2 and distribute, and that would then eliminate the y's. So now I have 5x plus 2y equals 22, and then I have -8. X, because I got to multiply by -2, minus 2y equals -34. So from that, I now get -3x equals what's renounced to, what, 12? Yeah, so -12, that's the difference between those two. And so divide by -3, divide by -3, so we get x equals 4. So if x equals 4, I can come plug that back into here, so we get 3 times 4 plus y equals 13. And so we get 12 plus y equals 13, or y equals, so minus 12 here equals 1. So we see that x4, y1, and for that reason, we're adding x plus y, so x plus y, which is 4 plus 1, gives me 5 as the answer choice, which is otherwise A. So a little bit helpful, but unfortunately on this one we can't really. We like to call these special values because quite often you'll have the means of a pattern to sort of cut through it to things. All right, let's look at the next one that we have here. We see that we have parallel lines. We see that we have angles. So remember, when we see parallel lines like L and M, we always want to look out for Z transversals. Okay, always want to be trying to look for those things. So it says in the figure below, line L is parallel to line M. So anytime you see this something parallel to each other, we can look for z transversals. If x equals 40, so if x equals 40, okay. What is the measure at D, E, F? So we're trying to look for this big angle right here. Well, one of the things I can understand is that, remember, z transversals, so we can kind of go through this and then through up here. So I understand that if this is 40, this is the inside angle of things, and then this has to also be 40 right here. So we have 40 and 40, and then we know collectively this is 180 and such. So for that reason, we should have 180 minus 40 and 40, which is the 80, gives me 100 degrees, which is answer choice B. Okay, so let's look at number 13 here. What we can see is this is which of the following equations represents the relationship between the diameter in inches of a giant sequoia tree and that tree's age in years and such. So let's just make sure we're comparing the same things. Here we're seeing, we see the diameter and we see the age of the tree in years. So we see, okay, yes, we're good here. And looking at this, we're just developing an equation that represents this graph here. And one of the things we can see is that we're at 0, so there's no intercept. And so for that reason, A and B are wrong. You can see that, and eliminate those as answer choices. So then we're just trying to figure out, well, what is this? Is it just half or 2x? And so we can see this is going to be 0, 0. And then we can pick any other point. We'll just pick this point. And so we see this one is going to be 50 and 100. And so then we can solve for the slope. Remember, it's the change in y over the change in x. And so we have 100 minus 0 over 50 minus 0. So 100 over 50. And so for that reason, we can see that the answer choice on this one is D and such. And so because you end up getting 2x or 2, so 2x is correct and C is wrong. All right, let's look at number 14 now. And 14, we see we have a rates problem. You see that because this especially tells us that, okay, we're dealing with the rates. And so we just got to be very cautious with our units. Assuming good growing conditions, how many years old is a giant sequoia tree with a trunk diameter of 19 feet? Okay, so 19 feet. So how many years old? And so it says with a trunk diameter of 19 feet. Trunk diameter. And we want to know how many years old is this giant sequoia? Well, here we see that we're in inches, right? And so here we're in feet. So we first have to then convert that over. So 19 feet, and then we'll multiply by the conversion factor, which is this right here. And we want to be in inches, times 12 inches over 1 foot. So now we see that the feet now eliminate each other as units, and you have 19 times 12. So if we do the calculation on that, and what we may happen to get there, and so 19 times 12 gives us 228 inches. So we can see that's going to be 228 inches of sorts. And so as we look through here, it's kind of going off the charts a little bit, right? So if we see 228, we see probably halfway distance here, be about up this level here. And so for that reason, we can see how it's sort of trending the age of this tree, the things. And so these are way too small. We see that. 494 just at 200. So if we see about 200 inches, we see it's just over 90. So we can approximate that C here, be the best answer choice. 494 is going to be way too large in regards to age and such. So that's eliminate that through logic. And then 15, it is what we're saying here. We see this is a linear modeling question. Remember what we call these modeling questions? And so these are basically giving us a formula, and we have to interpret what this is. And so keep in mind what we're looking at. So it says the linear model Z equals 43W, where can be used to find the height and feet of a giant sequoia tree. What does W represent? And so looking through this, we're trying to understand if this can be used to find the height, okay, height and feet of a giant sequoia. So that would be making reference to the Z, the things. Then we want to know, in relation to that, what would the other piece be? So if this is representation of the height, you can see is representation of the Z, then the W would have to be probably it'd have to be the age. And soft. So if we look over here, trying to, looks like another model that's trying to create things. I'm just trying to confirm that I'm really looking at what I need to look at and things. So this looks to be a little bit different. So remember, this model is very similar to, if you keep in mind, y equals mx plus b. Well, there is no b here thing, so that's been eliminated. So you're essentially looking at the m and the x, and the m is going to talk about the change. The x is going to be what's going to be an age, and so for the reason the only one that's talking about the age is answer choice answer choice A. 4/3, remember that's the slope, so it's going to be talking about the change of, the increase or decrease of something. So that, that's what the C and D ones are sort of making reference to partially. And then Z is making reference to the height of the tree in feet, so that's definitely not it. So using understanding that W is age, and we're making reference to the age here, we can choose confidently answer choice A. Okay, number 16 here, what we can understand about this is that we're looking at scatter plot or line of best fit, remember? And so this one is asking us, as a line of best fit is also drawn, which of the following is closest to the difference in cents per pound between the actual average production cost in 2012? And so we see average production cost, and so we see 2012, so that's 2010, 2011, 2012 here. So there's the actual, all right? And the average production cost has been predicted by the line of best fit. So remember, the line of best fit is going to be our model here. So that looks to be about right there, things. And so what we can see, that looks to be, say, about, I don't know, maybe 82. And so we can say maybe the predicted equals 82. And then looking at the actual looks to be about 90. And so which of the following is close to the difference here? So the difference of those two, and we can see the difference on those would be 8 or B is the answer choice. Okay. Let's take a look at number 17 here. So we see that we have an inequality question. It looks like we're developing an inequality thing. It says Emma mows a grass at a constant rate, so a constant rate of 1.5 acres per hour. So that rate, that means that's really talking about the slope that we have for this is equivalent to 1.5. She mowed 2 acres before lunch, okay, and plans to spend T hours mowing after lunch. If Emma wants to mow at least 8 acres of grass a day, which of the following inequalities best represents this situation? All right. And so what we're trying to understand here is we see that the slope or the increase is about 1.5. She mowed 2 before lunch. thing. So that's a 1.5t, 1.5t, 1.5t. So that makes it, so this is 2t, so that's out. And she wants to mow at least, so she wants to mow at least 8, if not more. So greater than, less than 8, greater than, less than 8, greater than, less than 8. So, okay, we see all that. Now here we see mowed 2 acres before lunch. And so for that reason, we're not taking, there's no 2 here. This is taking away 2, which is not true. And we want to add the 2 acres that we have for lunch, which is that one. So we can see C is the answer choice on this one. Okay, let's look at number 18. And in number 18, what we see is that we have a linear equation here, and we have a quadratic, right? And so we have a linear equation up top, and then we have a quadratic equation here that happens to be on the, the bottom that we have right here. So this one, I admit, it's probably one of the harder problems. I'm a little surprised. And it's more harder because of the constants. We see the k's are in here. And so anytime we have those in problems, we'll make it a little more challenging. And you just kind of have to work through some of the hypotheticals to really understand it. It says, in the situation above, k is a constant. When the equations are graphed in the xy plane, the graphs intersect at exactly 2 points. What's the following cannot be the value? Okay, so we want to know which one of these, when they so happen to be graphed, they do not intersect at the value or exactly at 2 points of things. So first off, we can help to move this one over. So let's convert this top one. And so which is going to be y equals negative kx plus 1. And the key thing here that we can understand about this one is that the intersect, or the y-intercept, is at plus 1 here. And then k is going to be the intercept that's always right here. So if we try to, like, say, draw, like, potentially, what's going on here, things. And if we say, for instance, that k is 3, okay, if k is 3, then we know we have a negative parabola, and it's doing something like this. So it's going 1, 2, 3, and then for that reason, we can see that it is kind of doing something like this, right, and stuff. And then along with that, it doesn't matter really what the slope is, since it's going to be at, it's a negative slope at positive 1, then we know it's going to be doing something kind of like this. So we know that it cannot be A for that reason. And let's look at 2 is kind of the same thing. Is like if we look at that, we know that the parabola again is going to be coming through negative 2 of sorts and doing something like this. And again, it's going to be going through positive 1, right? The linear equation is going to go through the y-intercept at 1, and so it's not going to be as steep of things, but still, you can see that it's going to be kind of coming through, and it's still hitting 2 points of this parabola, so it's not this one of things. And then looking at, actually I went to the wrong one. So I should have gone through right here and stuff instead, through negative 2. And then looking at the next one, we know that the parabola is going to come through right here, right? I know this is getting a little messy, but the premise is that here we now know it's a 1-to-1, and for that reason, it's going to go through this and kind of like up 1, down 1, and so still it's hitting through the parabola twice. So that only leaves D as an option. And so let me make a little bit cleaner one that we have here and stuff. And so if we have D as an option, we know the parabola is going to come through here, right? The things. And then if x equals 0 here, so if k equals 0, that's going to be negative 1, then we know that basically there's no slope, right? So there's no slope for that, and you have a positive 1 of sorts that'll go for that, because you have a negative, you end up having y equals negative 0x plus 1. And since there is no slope, that you're going through a positive 1, you'll be coming through this way, and there's not going through 1 points and stuff. And so D is the answer choice on that one. So again, that one you kind of have to be a little bit more mindful, inserting the values in and almost plotting them. The other thing you could always do just as well is, like, once you converted these, you could insert these into your calculator, graph the two out, and make sure that you're having 2 intersecting points with each one. But you kind of got to go through the process of elimination, unfortunately, through this one and solving for it. So it looks more challenging than what it really is. Okay, so let's look at number 19 here. Number 19 on this one, what we see is we're talking about mean, median, and mode. It says if 100 people played a certain video game, 85 scored more than 0 but less than 10,000 points. So, so we see that the points between 0 and, say, 10,000, and 85 people scored that, right? And then it says 14 scored between 10,000 and 100,000 points, right? And the remaining players scored 5.3, so we see that. So we see 5.35/00, so 5.3 million. So which of the following statements is true? So within that, remember, we've talked about this before on the bell curve of things, that when we have these things, and what our data is, remember the center here, the true center is always going to be the median. And then the mean is going to be pulled towards the outlier spike, remember? And so the mean, in this case, since this is being pulled way up because of this value here, that means the mean has to be greater than the median for that reason. Because the median is going to lie right here. The median is going to be number 49 and 50. With number 49 and 50 is going to lie in this column, in this row here. So we see the mean is greater than the median, and so the answer choice is A on this one. Okay, so let's look at number 20. We see we've got this two-way column, two-way table. So we got a two-way table. So we know we're most likely talking about some probability of things and things that maybe go along within that, some other stuff. Number 20, though, it says what percent of all the scores reported in the three studies were the 50 to 59 range. Well, we see in the three studies here, in the numbers, it says what percent of all the scores reported in the three studies. So we see 100, 200, 300. So it looks like there's a total of 600 participants there, right? And then from the 50 to 59, so 25, 40, that's going to give me 74. So 74 plus 88, 12, 16, so 162. So 162 are things. And so we'll do the math on that. So 162 divided by 600 gives me 27%, and that matches what I have here. So again, this would be 162 divided by 600, gives me 0.27. So that gives me answer choice D. And so make sure you're catching of all the scores reported here in the three studies. Okay, so let's look at number 21. So which of the following could be the median score in study 3? So that's the key point, study 3. And study 3 has 300 participants. Now remember, we're talking about median on the SAT. We want to look for the middle values. So we can split these. We know the first value, or the lower half, is going to be 1 through 150 because there's 300 of these folks. And then we have 151 through 300. Okay, so that makes the upper half, actually. Sorry, the upper half. And so these values are going to be in the middle. So we're not really concerned about what they are. We just want to know where these happen to exist. Well, in the first one, we see there's 88, right? And then in the second one, we see there's 67. Let me go ahead and kind of erase what I have here. All right, make this a little bit easier. So between these two, adding those, so 88 plus 7 is going to be 95. 95 plus 60 is going to give me 95 plus 60 is going to give me 155. So from that reason, I could see that the numbers 150 and 151 will fall in this range right here, fall in this range of values. So it has to be through 60 and 69. So therefore, the answer choice has to be B there. All right, and then number 22, let's look at it. It says the results of the study, the results of which of the studies can approximately be generalized to all 10th graders in Mistwick and to spring 2015. So let's take a look at this. So we're looking at this piece over here. Now, so study 1 was 10th graders were selected at random from all 10th graders in Mistwick. And so they were selected at random. And so it means all these results could be applied to all those students that are in the 10th grade from Mistwick. And this is asking to be generalized to all 10th graders in Mistwick in spring 2015. So that certainly seems like a very formidable choice there is number 1. So that seems okay. So that automatically takes out, remember we got Roman numerals here, takes out A, and it takes out C, right? Well, we see that 2, go to 2 here, study 2 is here. So really the only one that we need to check is study 3. So if we go check study 3, it says study 3, 300 10th graders from Mistwick volunteered. Well, remember, volunteering is not the same as being selected at random, and therefore those results cannot be generalized to the population. So that is wrong. So therefore we see B is the answer choice there. Okay, so let's look at number 23 for which we have here. 23, it says in 1979, Benjamin Franklin gave an amount of money to Boston, Massachusetts. The money was to be invested for 100 years in a trust fund. So a lot of times when we're talking about money, remember, we're talking about whether it's either a linear or exponential growth, whether it's linear or exponential. And the money was to be invested for 100 years, and the value of the trust fund doubled. Remember, we've seen this language a lot. Doubled every n years, especially doubled. So when we see doubled, that should automatically tell us that is exponential. Which of the following graphs best models the value of the trust fund over time for the 100 years? We know it's not linear. Again, this is not what we're looking for. This is not what we're looking for. We're looking as an exponential function means a growth parabolic function, which is C. All right, let's check out number 24 here and what we have. Okay. So this one we see that we have a pattern matching problem. We have polynomials. And within that we see the values of A, B, and C and that are going to be matching to this side. So we got to have this side match this side. And then the coefficients and constants that we'll have that will add up together to give us our answer choice of things. So let's go ahead and work on solving this one. And so we need to sort of distribute here, and then we want to combine. So the first one we have is x squared plus x, and then we'll have plus 2x plus 2, and all this is equivalent to this side. And so we see that is going to be that. So let's combine our like terms. We now have x squared plus 3x plus 2, which is an equivalent to ax squared plus bx plus c. And so here we see the a is equal to 1, because it looks on this side. The b is equal to 3, and the c is equal to 2. So you add up all those terms, you get 6, and you can see the answer choice on 24 is A. Okay, so let's look at number 25 here. So we see another scatter plot, so a line of best fit. And we see these equations. So what we're essentially trying to do is indicate as to what is the equation for this one that we're trying to develop. And quite honestly, we don't really need to understand what goes on in here. this really is not going to necessarily help me that much. So, but what I can see is that my intercept here is roughly about 47 or so. So what we understand is this is saying this is because this is line of which of the following could be an equation for the line of best fit. Well, there's no intercept here. There's no B here, so it cannot be A for that reason and stuff. 95.5, I guess, what does that give me? About 47. So if I do 95 divided by 2, so it's 47.5. So that seems to check out. That seems to check out. And then plus 55, which would be up here, so that definitely not. So after that, we're between B and C. Remember our divide and conquer strategies. And we just need to see what the slope is. So let's grab 2 points. Let's say I've got this one. So that's going to be 1 and 49 things. And then let's grab this one right here. Remember, it doesn't matter what 2 we choose. We just need to choose points. So that's 5 and what looks to be about 55. So again, the change in y over the change in x. So change in y is going to be 55 minus 49 over 5 minus 1. So that's going to give us 6 over 4, which is going to give me 3/2. Therefore, B is the answer choice and C is wrong there. So number 26, what we really are dealing with here is what it's asking of us is saying that how many, we see we have this polynomial, and it says if k are positive constants, so h is not equivalent to k, how many distinct x-intercepts does this graph have? And so what that really means, distinct, means different of things. Well, here, this is x minus h squared. Really what's going on is that we have a double root right here. And so there's really only one distinct x-intercept. And we know h, positive h is going to be different, and then positive k. So you have 1, 2, 3. So if we was really to try to say graph this, okay, if I was really trying to just make some guesstimation of what this graph would look like, okay, minus h would mean that we have a positive double root over here of things, and then that would be negative. These would both be negative intercepts. So I would have to have an intercept that kind of does this, and then does this, and then comes back and does something like this of things. And so then within that, I could see I'd have 1, 2, 3. And so C is the answer choice. Now, if we really want to know how many total roots, not distinct, but total roots, we would have 4 because of this double root of things. And so we can see that, be careful. We should hopefully be able to eliminate B and A quite easily. If you chose D, that means you did not pick up on that piece right there. Okay, looking at number 27, immediately we can kind of notice that we are dealing with a rates problem. Again, we see this sort of conversion factor that's given to us. And we also have scientific notation a part of this. So seems a little bit more challenging than what it is. Just remember, when we're working out these problems, is that we're trying to work from one unit to the next unit. And so sometimes you got to take that step by step and be patient as you're sort of working out this problem. So this one reads, a signal from a spacecraft orbiting Mercury travels to Earth at a speed of 3 × 10⁸ meters per second. Remember, that's a number over a number. So if the distance between Earth and a spacecraft is this, which of the following is close to the number of minutes it will take from the signal from space to reach Earth? Well, first we can realize we're in meters here, right? We see that here we're in meters. We're trying to go to kilometers. So that's the first step we're trying to do, is we have meters and we're trying to go to kilometers. And then secondly, we see we're in seconds and we're trying to go to minutes. And so that will be the next step, is go from seconds to minutes. So let's set up our first calculation. We have 3 × 10⁸ meters. okay? And that's over a second, so per second. And we want to go from meters to kilometers as we suggested. And so here's our conversion factor. So our conversion factor here would be times. And we want to get, 1 kilometer because that's the unit we want to be in. And then equals 1,000 meters, right? And so for that reason, the new value that we would then have would be basically 300,000 kilometers per second. However, we don't want to no longer be in seconds. We want to be in minutes. And so we can say, okay, well, times. Actually, sorry. And what I'm trying to do first here is I'm trying to get this value to match what we're trying to get into first. So that's why I'm converting this one first. Okay. Converting this traveling speed. So now we know that sorry. We want to get rid of seconds and be in minutes. And so for that reason, that would then be 60 seconds over 1 minute. Okay. And then after doing that calculation, we're now at 18. What we see is 1.8 times 10 to the 7th kilometers per minute. Okay. Well, if we're at 1.8 times 10 to the 7 kilometers per minute, and we at a distance from, it says the distance between Earth and the spacecraft is 2.0221 times 10 to the 8th kilometers. What's the following is closest to the number of minutes? Okay, so what we can then do is really to solve this is, and we want to be in the number of minutes, is we could say, okay, 2.0221, all right, times 10 to the 8th kilometers, and we want to be in minutes, right? So we need to take this piece here, right, and flip it. And so we want to know how many minutes, so we know that 1 minute we are traveling 1.8 times 10 to the 7th kilometers. So now we're eliminating kilometers, okay? So as you saw what I did, we have the kilometers, we have this conversion factor, this new conversion factor that we've just created by going through this chain here. And so in doing that, and so now we're eliminating kilometers, and ending up with minutes. And once we do that division fraction of sorts, let's see what we end up getting on a calculator. So we end up getting 11.23, which we can see the best answer choice here would be C for that reason. All right. Okay, number 28 here, we can see that we have a linear equation, right? And we have a special type of linear equation problem. We see that we're talking about no solutions. So remember, when we have no solutions, we need to have values that don't necessarily agree with each other, right? And so that means that when you're left with things. The other thing is that we always want to try to eliminate the x's, right? We want to be able to eliminate the x's. So for that reason, let's distribute. Let's get this first part done. So we see that we have negative 3xa, which is going to be minus a. And we can move this piece over here. So equals 7x minus x minus 2. All right, so now let's sort of simplify. So now we have negative 3xa minus a equals 6x minus 2. So what we're trying to do is, what value could we make x that would help me to get rid of 6x and that the two of these would not agree? Well, if we're looking at that, negative 3x equals 6x, that's probably the easiest thing to do, is negative 3x equals 6x. Well, then we'd have to say x then has to equal negative 2, right? So if we plug that back in, so we'll take this piece and plug it back into this equation, we're now going to have negative 3 times negative 2a, right? Actually, my apologies, that's the wrong step there. That should be really plugging in as the value of a here. So it should be negative, try that again, negative 3 times negative 2 times x, because this is the a value here, minus negative 2 equals 6x minus 2. So now if we FOIL here, we get 6x plus 2 equals 6x minus 2. And if we minus the 6x's here, you see these are gone, and you're left with 2 equals negative 2, which again, those are not equal, but that's what we want here because we're looking at no solutions. And so therefore, B is the answer choice on this one. That is the value of A. Okay, so let's look at number 29 that we have here. And we see another two-way table that we have. We have a two-way table here. And it's asking about probability. It says, if a lake has a high alkalinity class, so we see high right here, which of the following is closest probability that the lake also has a shallow depth of things? So one, we kind of, remember when we're looking at the probabilities, we're always looking at the number of possible, which should be under the number of favorable. And remember, the SAT is normally going to give you this first, then this second, in the way in which it leads to a statements of things. So if we're looking at that, we should see that, okay, the lake has a high alkalinity, so we know we're looking at this column, and we should be looking at the total value of this number. So then that's going to be 340, right? And then closest probably the lake also has a shallow depth here. So within that, you see B209. So if you do the math on that one, end up being 209 divided by 340, and you get 61.5. You get 0.615, which is 65%, which is going to be the answer choice of D there on that one. Okay. So that one definitely looks to be easier than what you would suspect for problem 29 problem. So hopefully you didn't trip over that one. And then 30 here, it says radioactive substance decay over time. The mass M, in grams of particular radioactive substance, D days after the beginning of the experiment is shown in the table below. Well, what we can take away from this is, remember, and you see this equation here, it's modeled by this equation, so M of D equals A times 10 times B times D. So what we have here is an exponential function. We know that. We have an exponential function problem. And one thing we see is it seems as D gets bigger, okay, as D grows bigger of things, this is really getting smaller. So what that is suggesting to us, traditionally, remember, if we're talking about exponential functions, if the x gets bigger, then the y also gets bigger, then you have what we call exponential growth. However, that's the opposite here on this one. So we can see that we see as x gets bigger, that the y is actually getting smaller, so we have something that's doing like this. All right, so let's look here. So we see the A here, the value of the A is really making use of what we call the principal. and what we start off with. And that's going to be, remember, it's always going to be this value here when x equals 0. Well, in this particular sense, with x equals 0, number of days, we see we're in 120. So therefore, that eliminates these values of things. So now we're looking and stuck between these. Well, we already said as x was getting bigger, y was getting smaller, so therefore our b term has to be negative and not positive, and so then therefore that makes D the answer choice here for this one. And so you can see the B up here, sorry, the B. It doesn't really matter what D is because D is always positive. You can see that being stressed here. The B is what's going to make it negative. Because you're going to have a, we write this out again. We have A times 10, which that's basically the percentage of which it's accelerating by. And so D is positive, so we know that you got a negative B term times a positive D term, which is always going to make this a negative term, which then is going to show that we have exponential decay here, which is this graph right here. Alrighty, so let's go and take a look at our grid ends for which we have here. And so looking at these, 31 is saying a scale drawing of a room uses a scale 2 centimeters equals 1 foot. So in the drawing, one wall has a length of 22 centimeters. What is the actual length in feet of this wall? So we see we want to be in feet. We see here in centimeters. So we can say, okay, we got 1 foot equivalent to 22 centimeters. Then same thing, we got a length of, sorry, whoops, too much there. 2 centimeters. 1 foot is equivalent to 2 centimeters. So then we want to, we have a length of 22 centimeters, and we want to know how many feet here. So we can cross multiply and divide. And so now we get 2x, 22 times 1 is going to give me 22. So x will then equal 11 here. And that would be your answer choice. All right, let's look at number 32 here. 32 says the function f has a property for all of x that 3 of f of x equals f of 3x. So if f of 6 equals 12, okay, what is the function of 2? Alrighty here. So what this is saying that if x equals 6, then y equals 12, right? And then so we're trying to figure out what that may so happen to mean for us, the things. So plugging that in, you see for all of x, so the 3 times a function of x equals f times 3 of x. All right, and so what we're looking at in this question here, is we said that x is equal to 6 and y is equal to 12. So we see a change here that the y is double as to what x is. And so it wants to know, well, if I have the function of 2, well, if x equals 2, then y would then equal 4 in this particular situation, because here we're saying that 3 times a function equals f times 3 of x. These are equivalent to each other, and so for that reason we know that because of this relationship is the same as well. Alright, so let's look at number 33 that we have here. 33, we can see we have a linear equation and we have a word problem here. It's asking if the profit P in dollars, so we can see P in dollars here, for producing and selling n units of a certain product is given by the equation above, where K is a constant. We have 200 units, so remember units is that's the same thing as n there, produced and sold for a profit of $12.75, so profit P in dollars, P, what is the value of K here? And so that we have these values, we have P equals 12.75 and that N equals 200. And as we sort of mentioned, the other day, or I'm sorry, as we sort of mentioned, is that, in these type of problems, we're going to match the units to the variables and be able to solve. So we have taking what we have above, So 1275 equals 9 times 200 minus, which would be 2 times 200, can run out a little bit of room, plus k, and so all that is together. So let's distribute and solve. So now we have 1275 equals 1800 minus 2 times 200 is going to be 400 plus k. So let's just make sure we keep our things straight. So we need to distribute the negative into this. So now this is going to be 1275 equals 1800 minus 400 minus k. So collectively together, we're going to have a little room on the bottom here. So again, it's just a little bit more, kind of making sure all of our ducks are in a row. Combine like terms, so 1400 minus k. Move this over here. So now you have 1275 minus 1400 equals negative k. And so then that you get a negative 125 equals negative k, and then you move the negatives, and we got that k equals 125. And there is our answer choice for number 33. Okay, so as we continue to move along here, let's look at number 34. Number 34, as we're looking in this, it says number of people in millions who visited amusement park A and amusement park B in 2009 through 2013 listed in the table below. So we see all these values here. So that's really just stating what's in here. So it doesn't make a difference. So what is the positive difference between the mean number of people in millions who visited amusement park B and the mean number of people who visited park A, and we're rounding to the nearest tenth. So what we then need to do is on our calculators, we just need to sum all the A values together. And so the sum of the A values, if we add those together, are going to be 15.7 plus 15.2 plus 14.4 plus 14.1 and 12.3. So we end up getting a value here of 71.7, and there's 5 values. And so we're going to end up getting a value there that's going to be 14.34. All right, so let's look at amusement park B now and sum up all those values together. So 15.9 plus 16 plus 16.1 plus 16 plus 16.2, and we're going to get 80.2. So we're going to get 80.2. It's a 0 there, over 5, divided by 5, and we get a value of 16.04. So take the difference of those two, 14.34, you're going to get a value that is going to be 1.7, and that is our answer choice there. All right, so let's look at number 35 here, and what we have. Number 35 is, we see is T and W are parallel lines of the XY plane. The equation of the line T is 4x plus 7y equals 14, and line W passes through negative 3, 8. What is the value of the y-intercept of line W? So these are parallel. And if these are parallel, that means that the slope is the same for the two. So let's look at this real quick for line T. Let's find the slope of line T. So we have 4x plus 7y equals 14. So then I need to move this piece over here. So now I have 7y equals 14 minus 4x. And then I need to divide by 7 here. Divide by 7. And so now I want to get y equals 2 minus 4 over 7x. So our slope here for T is negative 4 over 7. All right, so there's a slope. So we're going to apply that to the other one, to W. So W remember, is we have this point, we have negative 3, 8. So that's the same thing as our x and y values there. So we can rewrite this equation. Since it's a line, it's going to be, let me just say y equals mx plus b. So there's a y is 8. So 8 equals, the slope is, since it's parallel, is negative 4/7. Negative 4/7 times the x, which is negative 3. And then plus b. So working on this, that's the same thing as 1. So that's going to be negative 3/1. So now we have 8 equals, which will be positive 12, because negative 4 times negative 3 is going to be positive 12/7 plus b. And then we need to subtract this and move it over here. So what we can then do is, since we have a common denominator or 7, 8 times 7 is going to be 56. So now we have 56/7. That's the same thing as 8. Okay. Minus 12/7 equals b. And so what you end up getting is 44/7 equals b. And that's it. That's our answer choice for that one. Okay. All right, let's look at number 36 here. 36, what we see here is we have two triangles within that. So within this, we can automatically kind of assume that we're dealing with similar triangles, okay? And that's what we have here. And it says, in the figure above, ABC and DC, right triangle CD equals 20. So we saw this is equal to 20. The tangent of angle ABC is 2.5. So if we look at angle ABC, that means we're looking at this right here. All right, ABC. And so the tangent of, which is really angle B, is opposite over adjacent, which is going to be 2.5/1. Okay? So that means that the opposite here, so we know that the ratio of this triangle, of this long leg of AC and DC, is in ratio of 2.5, okay? And actually, let's draw that in a different color to make it a little bit more distinguishable. So let's make that, it's going to be 2.5, and the ratio of this leg is going to be 1, because this is what we're looking at here. Angle B, opposite, adjacent. And we want to know what is the leg segment of ED things. So within that, we can kind of label our legs. We know this is, we can just say this is leg 1, and AC is leg 1. And then BA can be leg 2, and ED can be leg 2. So with the ratios that we have, we know this is 20 DC, right? So we can say, okay, we can say that DC over ED is going to be equivalent to AC, the whole thing, over BA. And from there, we say we know that DC equals 20. We don't know what ED is. AC is in ratio of 2.5, and BA is in ratio of 1. So we know those are known values, right? That's for what we have. And so there we cross multiply and divide. So now we have 2.5x equals 20. We do have the use of our calculator on this section, so let's divide there. So 20 divided by 2.5. So x equals 8. So x equals 8 the things. And then therefore, that is, x is equivalent to ED. And we can therefore see that our answer choice here is 8. So it's 8. All right. So let's look at number 37 here and what we have for this one. 37, we have this table, tells us the recommended amount. And so here it's saying Andrea's recommended daily intake of potassium is 50% greater than her 2-year-old brother. What is the least possible age in years of Andrea. So her 2-year-old brother, which we see potassium intake would here be 3,000, and her intake is 50% more. So remember with these percentage, it's either working with decimals or change of. So this is a decimal problem, so that means you're increasing or decreasing off 100%. However, this is 50% greater, so that means the decimal is 150%. So to multiply that, that would be 3,000 times 1.50, which will then give us a value of 4,500 milligrams. Well, 4,500 milligrams, let's see where that's what happened to the fall, is right here. And it says, what is the least possible age? The least possible age is 9. Okay. All right, and then number 38 says what the recommended daily intake of potassium for an 8-month-old is what fraction of that of a recommended 2-year-old. And so we can see the 8-month-old, looking at it, looks to be right in this column, 8-month-old, so that would be 700. So 700. And then the 2-year-old child, which we've already established, is 3,000. Drop some of these zeros, you end up with 7 or 30. Or I think the decimal of that one is going to be 0.233 if you choose to grid those in. So either one of these is the right answer choice. All right, well, thank you so much. I certainly hope you appreciate all this and was giving you some additional insight on how you may want to approach certain problems, and that you were able to, make some strides in your math concepts. Thank you so much, and wish you well next time.